Okay, so we're going to talk about geometric series, which is the second big concept in section 10.2. And the idea is that we have a series of the form of the sum. We're going to go from n equals sum, maybe capital M, up to infinity, of some constant a times r raised to the n. So it's generally some number raised to the n power. And we're going to say that's convergent if r, the absolute value of r, so we're going to ignore positive negatives, is less than 1. And its sum, so if it does in fact converge, we can say its sum is a times r to the m over 1 minus r. And if r is greater than or equal to 1, the geometric series is going to diverge. So the question is, where does this formula come from? And the formula, like the main formula here, where does it come from, and how do we get that formula? So we're going to think about the idea that if we take partial sums, so if we take the partial sums of this formula, we're going to go ahead and assume that m is 0 because that's a case that is easiest, and the other cases could be done similarly, but we're going to assume that in fact we are starting at the sum of 0. So if we were going to sum this stuff, we would get a plus a times r plus a times r squared, and we would keep doing that all the way down to a r to the n. And similarly, we could take that same sum and multiply it by r, and we would get ar plus ar squared plus ar cubed, and we would do all that all the way down, and we would get ar to the n plus 1. So then, if you think about those two sums and subtract them, you would get Sn minus Rsn, and if you look up here at these two and subtract one from the other, it looks like all this stuff here in the middle would cancel, and you would really just be left with two terms, an a, and the last term, I guess it would turn into a minus. Let's see, I think it would turn into a minus a r to the n plus 1. And if you were to simplify that, we would get a times 1 minus r to the n plus 1. And if we're looking over here at our sum on the left-hand side over here, we could factor out Sn, and we'd have Sn times 1 minus r would equal a times 1 minus r to the n plus 1. And if we were trying to find out what our Sn is equal to, we could say that Sn would therefore equal a times 1 minus r to the n plus 1 divided by 1 minus r. And that's all assuming that r is not equal to 1, because then we would be dividing by 0, and that would be not a good thing. So generally, this is what our partial sums will sum to. Sn is the partial sum that we looked at up here, and once we did this really cool subtraction thing, we found that those partial sums, Sn, will generally total a times 1 minus r to the n plus 1 over 1 minus r. So we're going to take that partial sum limit, Sn, so we know that Sn is a times 1 minus r to the n plus 1, and all of that is divided by 1 minus r. And if we take the limit as n goes to infinity, that's how we determine what our partial sums converge to, which tells us what the sequence converges to. So if we take on the same side the limit as n goes to infinity of a to the 1 minus r to the n plus 1 over 1 minus r, if r is less than 1, then we would hopefully recognize the limit as n goes to infinity of r to the n plus 1 is going to be what? That's the big question. So as r is less than 1 and n is getting really large, so this is getting really big, and we're thinking about r being a number less than 1 and obviously greater than 0. And so if we think about that, it's going to get closer and closer and closer to, we take a really small number and raise it to really large powers, hopefully you can recognize that that's going to go to 0. But if r is greater than 1 and we take the limit as n goes to infinity, we would see that r to the n plus 1 is going to go to infinity, probably, because r is a big number. It's bigger than 1, so you can think of this as a big positive number raised to an infinite power that's going to continue to get really large. So in this case, we have two situations, one if r is less than 1 and one is r is bigger than 1. And in those two cases, we kind of get two different answers. And so in this case, this whole fraction up here, the whole fraction for the limit, this limit in this case would diverge because it would get really large. But in the first case, in this case where we get 0, if we plug that in, for if r is less than 1, that's when we would get the a over 1 minus r, which if you go back and look at that formula, if, so this is r to the 0, that's the a times r to the m over 1 minus r. So that is exactly where that comes from for those specific values, and that only leaves you the case that if r is equal to 1, and if r is equal to 1, then what you're really doing is taking the sum from n equals 0 to infinity of a, just a's. So you're really just taking a plus a plus a plus a, and you're doing that forever. And if you do that, then hopefully you see that that's going to go to infinity, and so there's no way that that will converge either. So the limit of the partial sums in that case would go to infinity, and that would therefore also diverge. And you can do a similar idea if r is negative 1. But I don't think we have to do negative 1 as a separate case because you don't get a problem in the denominator in terms of when you divide. So hopefully that process kind of shows you where that formula, the a r to the m over 1 minus r, comes from. So that's what this process was here for you, is to see where the formula c times r to the m, or a times r to the m over 1 minus r comes from. So now we're going to try to use that formula with some specific examples. So the first one we have here, I'll write it a little bit bigger up here. We're going to go the sum n equals 0 to infinity of 7 times 3 to the n over 11 to the n. And our first goal here is to get it in the form, so remember everything needs to be in the form of the sum of a times something raised to the n. And that needs to go from n equals, in this case, 0 to infinity. So here we're going to rewrite this summation. This is the sum n equals 0 to infinity of 7 times 3 over 11 raised to the n. So the two things that are raised to the n are 3 and 11. So we're going to take those and create one fraction, 3 over 11 to the n. We note that 3 over 11 is less than 1, so we know this series converges because it is a geometric series with 3 11ths. And in this case, we can then use the formula. Remember, it's a times r to the m over 1 minus r. So in this case, we know that the sum is going to equal 7 times 3 11ths to the 0 over 1 minus 3 11ths. And if we simplify that fraction, I think we will get 7 over 8 11ths. And if we simplify that, we should get 77 over 8. So that's our first example of a geometric series. We have one more example that's a little bit more interesting, and in this case we're going to start at n equals 1, and we have 4 times 5 to the n. Again, I'll write this up here if this is too small to see. 4 times 5 to the n minus 5 times 4 to the n, and all of that is divided by 6 to the n. And so what we need to do here is create a couple of fractions, or a couple of series, so that we can actually see if each piece converges, and then if each piece converges, then we'll know that the whole series converges as well. So here we'll write this as the sum n equals 1 to infinity. We'll take 4 times 5 over 6 to the n, and then we'll subtract the sum, n equals 1 to infinity. 5 is our extra term, and this time it's 4 over 6 raised to the n. So all I did was split this fraction into two pieces, sort of this one, right, and then minus this one. So it's two fractions, 4 times 5 over n to the 6, 5 over 6 to the n, and then minus, we set a separate one, 5 times 4 over 6 to the n. So just divided the fraction into two pieces and simplified. And in this case, we're going to get that this one will definitely converge since 5 over 6 is less than 1. And this one is also going to converge since 4 over 6 is less than 1. So we know the whole thing converges. So we have two convergent pieces being subtracted. We'll definitely get a number. So for the first one, we'll do 4 times 5/6 over 1 minus 5/6. And then we'll subtract 5 times 4/6 over 1 minus 4/6. So that's again using this formula, a times r to the m over 1 minus r, and in this case, notice that m is equal to 1, so we're getting a 5/6 to the 1 on top. And so then if we actually finish all of this out, you can do some multiplication here. I think we get a 20 for the first term, and we get a 10 for the second term, and so we get a final answer of 10 as the sum of that geometric series. Hopefully that helps a little bit for you to understand the concept of a geometric series, and we will practice some of these in class next time.